Hi all, this is the first lesson for Unit 5 Process Heat Flows, and we're gonna treat about possibilities for heat integration and the heat cascade. One way to calculate heating and cooling needs is divide the problem in arbitrary intervals of temperature. Then calculate the energy balance for each interval, taking as negative if heat is in excess and positive if heat for the interval is in default. And finally, use heating or cooling as needed for each interval, summing up the total heating and the total cooling. As you can see here, the total needs for heating are 12,000 kilowatts or whatever, and total need for cooling is 11,000. But heat can flow spontaneously down the problem from high to low temperature. It can cascade down the problem. If positive, it is in excess, it can be directed down or go to cooling. If negative, it is in default, it must come from up or from heating. In this way, heating can be safe. Some heating can be safe. And if heating is safe, cooling too, because the balance must be met, the balance for the whole process. In this example, heating has been reduced from 12,000 to 7,000, and in the same extension, cooling has been reduced from 11,000 to 6,000. This is the concept of heat cascade. The detailed calculation can be performed using the problem table algorithm that will allow us to calculate minimum heating and cooling energy flows, where pinch or pinches are located in the problem, and also the grand composite curve. This is the temperature versus heat flow profile that will be very useful in our problem studies. And all this without having to draw or having to place or match the composite curves, just calculating. We will see it in the next lesson.